Hi, my name is Jessica Linville. I am CEO and founder of Ready Solutions. We are commercializing the Ready Water pre-treatment system developed by Argonne National Lab to reduce cooling tower operating costs by 20%. As most of you know, freshwater scarcity is becoming more of a problem within the United States. This is causing the cost of water to increase. In fact, municipal water and sewer prices have nearly doubled since 2010 in 30 major U.S. cities. This graph shows the difference between the overall consumer price index and the consumer price index for utilities. The water and sewer cost is increasing at a rate faster than all other utilities combined. What might be surprising is that 60% of water consumptions at an institution, such as a university or hospital, is for their cooling towers. This is a picture of a cooling tower at a hospital in Las Vegas. Cooling towers are air conditioning devices much like the one in your home. However, unlike the system at your home, which uses air to reject heat, these towers use evaporating water to expel heat from the system. There are over 500,000 cooling towers in the United States outside of power plants, using nearly 4% of all of our fresh water per year, or roughly 5 trillion gallons per year. So let's take a closer look at how a single cooling tower operates. Here's a typical large cooling tower like those found at major universities. It uses roughly 22 million gallons of fresh water per year, or the equivalent of 700 people. Roughly 70% of that water evaporates to cool the facility. As the water evaporates, scale-forming ions build up in the system, which requires the addition of chemicals to maintain the cooling tower infrastructure. Once those ions reach a certain level, they must be removed from the system through a mechanism called blowdown. Those ions are sent to the sewer. This results in an operating cost of $160,000 per tower. A single institution can operate between 4 to 10 cooling towers. The industry predominantly uses chemicals provided by water treatment service companies to manage scaling, corrosion, and biological fouling in these cooling towers. The chemical treatment offers limited ability to conserve water by increasing the amount of chemicals added to the system. However, the increased cost of chemicals are offset by any reduction in water expenses. Chemical addition is also labor-intensive, requiring 2 to 3 site visits per week by the service company. There are a few niche technologies available in the market to replace chemical treatment, but these technologies have not received widespread adoption due to their limited field of use and practical performance limitations. The Ready Water reduces the operating cost by 20%. As a pre-treatment system that allows the cooling tower to operate more efficiently. More specifically, it reduces municipal water costs by 15%, the sewer cost by 55%, and the chemical cost by 40%. This results in an average saving of $35,000 per year and 3 million gallons of water per year. The payback period for our system is roughly 3 years. The Ready Water system is a fundamentally improved electrodeionization process, which improves the water quality unlike our competitive processes. The Ready Water technology is built from commercially available components and Argonne's patented resin wafer design to enhance the system performance and flexibility. The inventors Yupo Lin and Seth Snyder have over 25 years' experience in water technology development. If you stack the resin wafers that they've invented into a water treatment device, you can use electricity to pull the scale-forming ions into a reject water stream, sending purified water to the cooling tower. Our device is easy to retrofit into existing infrastructure, has a modular design to scale to various size cooling towers, and we maintain the existing chemical treatment system to increase reliability. As I mentioned before, this technology has been developed at Argonne National Lab, with funding from the Department of Energy. There is a total of 17 patents and 50 peer-reviewed papers surrounding the extensive research on this technology. The Argonne scientists have scaled this technology from bench to pilot scale, which they've run in the lab for over 2,000 hours. We have licensed the 5 core patents for the water application and have received a $250 investment to build a small commercial unit for field demonstration early next year. From there, we will scale manufacturing and begin selling this technology. We have secured our first pilot customer with the University of Chicago, but we are seeking additional locations in the Southwest to decrease our project timeline. We are targeting the Southwest due to the high scale-forming water hardness, making water conservation difficult in cooling towers, coupled with the frequent droughts, increasing the need for water conservation. Many municipalities in this region have rebate programs which can reduce the capital equipment cost for water conservation efforts in cooling towers by up to 50%, further incentivizing the use of our technology. Our target opportunities will focus mainly on hospitals, universities, data centers, airports, and large office complexes. Many of these institutions have sustainability goals and are more open to innovation. We have identified 1,000 institutions in our target market with over 6,000 cooling towers. Our system has the potential to reduce operating costs by $210 million and water consumption by 18 billion gallons annually. This is Clay Looney. He is an operational manager at the University of Texas and is our ideal customer. The university operates 7 cooling tower stations. It uses 350 million gallons of water per year and spends approximately $2.75 million in cooling tower operating costs. He has been looking for ways to reduce the cooling tower cost, and he has switched one of his chilling stations to reclaimed water. However, the lower quality of the water increases his water and chemical consumption, negating the reduced cost of the reclaimed water. His key influencers for the purchase of a new system is utilities and facilities upper management, which have to sign off on purchasing new technologies, and the sustainability director, which is setting mandates to reduce water and energy use. He is actively searching for ways to conserve water and thinks the Ready Water technology would be a real plus. We initially plan to sell directly to our end users. This will allow us to have a closer relationship with them and to provide better service. As we scale the technology, we plan to partner with water treatment service companies to manage the cooling. We plan to partner with water treatment services companies that manage the cooling towers today. This sales strategy will leverage our partners' existing customer base and sales force to expand rapidly geographically while keeping our staffing low. We will incentivize the use of our technology through a shared service contract, which will increase their profit and reduce their chemical cost. We plan to partner with one company per geographical location, which will give them a competitive advantage. This business model will also allow for constant monitoring of our system, as with the current chemical service model, which will benefit our customers. There are 2 revenue streams for this technology: an $80,000 upfront capital cost and a $10,000 per year service contract. This comes to a total cost of $180,000 to our customers over 10 years, with a cost savings of $350,000. Considering the annual $35,000 in saving the customer receives, they have a simple 3.2-year payback period for our system. Of the $80,000 install device cost, 41% of that, or $41,000, goes to materials, COGS, and installation, and a royalty payment to Argonne. What we see is a 45% margin on the technology. Of the yearly service contract, roughly $3,600 goes to materials, royalties, and our partner service contract. We see 65% margins on this. An institution with 6 cooling towers has a lifetime value of nearly $600,000. Armed with the information from our field validation, we will secure 3 customers in 2018, and then continue this into 2019 and 2020, when we grow our team to over 20 employees. Those 20 people will be used to initially penetrate the cooling tower market nationally and begin selling to other cooling tower segments. From there, we'll begin targeting our adjacent markets and to scale manufacturing in 2021 and 2022. Our adjacent markets include commercial kitchen applications and small community water systems. By 2022, we will achieve $32 million in revenue. Our team right now consists of myself, a CEO and founder. I have a PhD in engineering and have participated in 4 accelerators to build the business model. Brian Pollock is our VP of Sales and Marketing. He has over 10 years in B2B sales experience. We have partnered with an engineering firm to build our first unit and are using MBA students to help us with our financial projections. We are actively seeking a VP of engineering. Our mentors include a technology inventors from Argonne National Lab as well as industry leaders. Once we have the data from the unit demonstration early next year, we will be seeking an additional $850,000 investment for further market validation by reaching 3 paying customers. The investment will go towards scaling manufacturing of the patented resin wafer material and hiring additional employees. Thank you. I'd be happy to answer your questions.